Sampling methods and the central limit theorem. Sampling is a tool to infer something about a population. We begin this chapter by discussing methods of selecting a sample from a population. Next, we construct a distribution of the sample mean to understand how the sample mean tend to cluster around the population mean. Finally, we show that for any population, the shape of the sampling distribution tends to follow the normal probability distribution. Sampling methods. Reasons to sample. 1. To contact the whole population would be time consuming. 2. The cost of studying all the items in population may be prohibitive. 3. The physical impossibility of checking all items in the population. 4. The destructive nature of some tests. 5. The sample results are adequate. Question 1. In your opinion, what is simple random sample? Question 1. In your opinion, what is simple random sample? Simple random sampling. A more convenient method of selecting a random sample is to use the identification number of each employee and a table of random numbers such as the one in Appendix B.1. As the name implies, these numbers have been generated by a random process, in this case by a computer. For each digit of a number, the probability of 0, 1, 2, and 9 is the same. Thus, the probability the employee number 011 will be selected in the same as for employee 722 or employee 382. By using random numbers to select employees, bias is eliminated from the selection process. A portion of a table of random numbers is shown in the following illustration. To select a sample of employees, you first choose a starting point in the table. Any starting point will do. Suppose the time is 3:04. You might look at the third column and then move down to the fourth set of numbers. The number is 03759. Since there are only 845 employees, we will use the first three digits of a 5-digit random number. Thus, 037 is the number of the first employee to be a member of the sample. Another way of selecting the starting point is to close your eyes and point at a number in the table. To continue selecting employees, you could move in any direction. Suppose you move right. The first three digits of the number to the right of 03759 are 447. The number of the employee selected to be the second member of the sample. The next three-digit number to the right is 961. You skip 961 because there are only 845 employees. You continue to the right and select employee 784, then 189, and so on. For example, Amel and Ando operate the Fox Sport Inn, a bed and breakfast in Tryon, North Carolina. There are 8 rooms available for rent at this B&B. List below is the number of the 8 rooms rent each day during June 2011. Use Excel to select a sample of 5 nights during the month of June. You guys can see in this picture. The solution, Excel will select the random sample and report the result. On the first sample day, 4 of the 8 rooms were rent. On the second sample date in June, 7 of the 8 rooms were rent. The information is reported in column B of the Excel spreadsheet. The Excel steps are listed in the software comments section at the end of the chapter. The Excel system performs the sampling with replacement. This means it is possible for the same day to appear more than once in a sample. Systematic random sampling. Systematic random sample. A random starting point is selected, and then every KTH member of the population is selected. For example, suppose the sales division of Computer Graphic Inc. needs to quickly estimate the mean dollar revenue per sale during the past month. It finds that 2,000 sales invoices were recorded and stored in file drawers, and decides to select 100 invoices to estimate the mean dollar revenue. Simple random sampling requires the numbering of each invoice before using a random number table to select the 100 invoices. The numbering process would be a very time-consuming task. Instead, we use systematic random sampling. Question 2. Give an example in real life about systematic random sampling. Question 2. Give an example in real life about systematic random sampling. Stratified random sampling. Stratified random sample, a population is divided into subgroups called strata, and a sample is randomly selected from each stratum. When a population can be clearly divided into groups based on some characteristic, we may use stratified random sampling. It guarantees each group is represented in the sample. The groups are also called strata. For example, college students can be grouped as full-time or part-time, male or female, or traditional or non-traditional. Once the strata are defined, we can apply simple random sampling within each group or stratum to collect the sample. Question number 3. When we use the stratified random sampling method, Question number 3. When we use the stratified random sampling method, cluster sampling. Another common type of sampling is cluster sampling. It is often employed to reduce the cost of sampling a population scattered over a large geographic area. Cluster sample, a population is divided into clusters using naturally occurring geographic or other boundaries. Then, clusters are randomly selected and a sample is collected by randomly selecting from each cluster. Cluster sampling. These are often called primary units. Suppose you divided the states into 12 primary units, then selected at random 4 regions, like 2, 7, 4, and 12, and concentrated your efforts in these primary units. You could take a random sample of the residents in each of these regions and interview them. Note that this is a combination of cluster sampling and simple random sampling. You guys can see the example. Question 4. Give your opinion about cluster sampling. Question 4. Give your opinion about cluster sampling.
Methods. Probability sampling is non-probability sample inclusion, and the sample is based on the judgment of the person selecting the sample. The sampling error is the difference between a sample statistic and its corresponding population parameter. Question 5. What is the difference between non-probability sample and sampling error? Question 5. What is the difference between non-probability sample and sampling error? This is the example of sampling distribution of the sample mean. The sampling distribution of the sample mean is a probability distribution consisting of all possible sample means. Probability sample size of a population is about employee, hourly earnings, and all the times are equals to the table. Question 6. In your opinion, what is observation can be made about the population and the sampling distribution? Question 6. In your opinion, what is observation can be made about the population and the sampling distribution? Question 7. What is mean in the sampling distribution? Question 7. What is mean in the sampling distribution? Here is the example of sampling distribution of the sample means example. The population mean is $7.71 found by 7 plus 8 plus 7 plus 8 plus 9 divided by 7 equals $7.71. So to arrive at the sampling distribution of sample mean, we need to select all possible samples of 2 without replacement from the population, then compute the mean of each sample. There are 21 possible samples found by using formula 5 to 10. This is the next example about sampling distribution of sample means. And this is all about sample, employee, hourly earnings, the sum, mean, and sample employees hourly earnings sum. Mean. Question 8. In your opinion, why is sampling distribution so important in daily life? Question A. In your opinion, why is sampling distribution so important in daily life? Question 9. What the difference between population values and the sample mean? The central limit theorem. The central limit theorem, if all samples of a particular size are selected from the N population, the sampling distribution of the sample mean is approximately a normal distribution, and this approximation improves with the larger sample. Question 10. Basic on your perspective, what is the central limit theorem? Question 10. Basic on your perspective, what is the central limit theorem? The population follows a normal probability distribution. Then for any sample size, the sampling distribution of the sample mean will also be normal. If the population distribution is symmetrical but normal, the normal shape of the distribution of the sample mean emerges with the sample as small as that. If a distribution that is held or has thick colors, it may require samples of 30 or more to observe the normality feature. The mean of the sampling distribution equal to and the variance equal to. Using the sampling distribution of the sample mean, as we know, sigma norm. If a population follows the normal distribution, the sampling distribution of the sample mean will also follow the normal distribution. If the shape is known to be non-normal, but the sample contains at least 30 observations, the central limit theorem guarantees the sampling distribution of the mean follows a normal distribution. To determine the probability the sample mean falls within a particular regime, and we use the formula in this example. Question 11. In your opinion, why the central limit theorem guarantees the sampling distribution of the mean follow a normal distribution? Question 11. In your opinion, why the central limit theorem guarantees the sampling distribution of the mean follow a normal distribution? Using the sampling distribution of sample mean as we know sigma acknowledged. This is the second example. The population does not follow the normal distribution, but the sample is of at least 30 observations. The sample means will follow the normal distribution. And to determine the probability a sample mean falls within a particular region, we use this formula. Next, we're using the sampling distribution of the sample means of known sample. The quality assurance department of cola aims to maintain records regarding the amount of cola in its jumbo bottle. The actual amount of cola in each bottle is critical, but varies a small amount from the one bottle to the next. The cola inns does not wish to underfill the bottles. On the other hand, it cannot overfill its bottle. Its records indicate that the amount of the cola follows the normal probability distribution. The mean amount per bottle is 31.2 ounce and the population standard deviation is 0.4 ounce. At 8 a.m. today, the quality technician randomly selected 16 bottles from the filling line. The mean amount of cola in the bottles is 31.38 ounce. Is this an unlikely result? It's likely the process is adding too much soda in the bottles. To put in another way, is the sampling error of 0.18 ounce is usual. Using the sampling resolution of sample mean as the sigma of known example. Step 1. Find the z values corresponding to the sample mean of 31.38. And this is the result about the formula. Next, using the sampling distribution of the sample mean as the sigma known example. What do we conclude? It is unlikely less than 4% chance we could select a sample of 16 observations from a normal population with a mean of 31.2 ounce population standard deviation of 0.4 ounce and find the sample mean equal to or greater than 31.28 ounce, then we conclude the process is putting too much cola in the bottle. Thank you.